In this video, we're going to continue our discussion of bottom-up parsing with the main strategy used by all bottom-up parsers, so-called shift-reduce parsing. Here's a quick review of the most important thing that we learned last time, that a bottom-up parser traces a rightmost derivation in reverse. Now, this particular fact has an important consequence. So let's think about a state of a shift-reduce parse where we have some strings alpha, beta, and omega. And let's assume that the next reduction is going to be to replace beta by x. Okay, so remember we're running productions backwards. Then I claim that omega has to be a string of terminals. And why is that? Well, if you think about it, if this is a rightmost derivation in reverse, then when x is replaced, when we take this, if we look at the forward step instead of the backward step, so remember the parser is running this way, replacing beta by x, but if we think about the rightmost derivation in the other direction, then x has to be the rightmost non-terminal, which means there are no non-terminals to the right of x. And so all the characters, all the tokens or whatever it is in this string have to be terminal symbols. Now it turns out that those terminal symbols to the right of the rightmost non-terminal are exactly the unexamined input in bottom-up parser implementations. That is, if I have alpha x omega and x is my rightmost non-terminal, then this is the input that we haven't read yet. This is unexamined input. And it's going to be useful to mark where we are in the parse, where our input focus is. And we're going to do that by using a vertical bar. So we're going to just drop a vertical bar between the place where we've read everything to the left, and we've actually been working on this. So this stuff to the left here can be terminals and non-terminals, and the parser has seen all of that stuff. And the stuff to the right is stuff that the parser hasn't seen yet. We don't know what's out there, although we do know it's all terminal symbols. And the vertical bar is just going to mark the dividing line between the two substrings. To implement bottom-up parsing, it turns out we only need two kinds of actions, shift moves and reduce moves. And we've already talked somewhat about reduce moves, and so we have to introduce shift moves. So let's do that now. So a shift move reads one token of input, and we can explain that or represent that by moving the vertical bar one token to the right. So if our input focus is here and we want to read one more token of input, then we just move the vertical bar over, and this signifies that now the parser knows about that next terminal symbol, and now it can start working on it. It can do things with it and match against it for the purposes of performing reductions. Again, the stuff out here to the right of the vertical bar the parser hasn't seen yet. And then a reduce move is to apply an inverse production at the right end of the left-hand string. So if we have a production, A goes to xy, and we have x and y here immediately to the left of the vertical bar, so this is our focus point, okay, and x and y, the right-hand side of the production is right there, then we can do a reduction. We can replace that right-hand side by the left-hand side. And this is a reduce move. Here is the example from the last video, and this is exactly the example, just showing the reduce moves, now with the vertical bar also shown. So this shows where the input focus was at the point where each of the reductions was performed. And what's missing, of course, now we know, is the sequence of shift moves. So here is the sequence of shift moves and reduce moves that take the initial input string to the start symbol. So let's walk through this in more detail. So we're going to go step by step, and we're going to show each shift and each reduce move. And now, in addition to our input string down here, we also have a pointer showing where in the input we are. So initially we haven't seen any of the input, and our input pointer is to the left of the entire string. So the first move is to do a shift. And then we do another shift, and then we do another shift. And now, just looking at the example from before, if you look back at that example, you know the next thing we need to do is a reduce. And remember, we're only allowed to reduce to the left of the arrow. So we can only reduce over on this side of the arrow. So we always have to have read enough of the input before we can perform a reduce move. And then we perform another reduce move. Okay? And then it turns out the next thing to do is two shift moves, and we haven't explained yet how we know whether to shift or reduce. We're going to get there. I'm just showing that there exists a sequence of shift and reduce moves that succeed in parsing this example. Now we've shifted the entire input onto this. We've shifted over the entire input, so there's no more input to read, and now all we can do is reduce moves. But fortunately, there is a sequence of reduce moves from this point that we can perform. So here we reduce int, and then we reduce t plus t. Oh, forgot. We first reduce t to e, and then we reduce t plus e back to the start symbol. It turns out that this left string, the stuff to the left of the vertical bar, can be implemented by a stack. And that's because we only do reduce operations immediately to the left of the vertical bar. So it's always some suffix of the string to the left of the vertical bar where the reduction is happening. So what a shift move then does is to push a terminal onto the stack. It reads one token of input and pushes it on the stack. And then a reduce pops some number of symbols off of the stack. That's the production right-hand side. And then it pushes one non-terminal onto the stack. That's the production left-hand side. Now it can happen that in a given state that more than one action, shift or reduce, may lead to a valid parse. So in particular, if it's legal to shift or reduce, if you could do either one of those things, then we say there is a shift-reduce conflict. The parser could either read one token of input and push it on the stack, or it could perform a reduction. If it's legal to reduce by two different productions, then there is what is called a reduce-reduce conflict. Okay, so reduce-reduce conflicts are always bad, or almost always bad. They indicate usually some kind of serious problem with the grammar. Shift-reduce conflicts are not good, but they're often easier to remove. So if you have reduce-reduce conflicts, particularly when you're building your grammar for cool, then you're doing something seriously wrong. If you have shift-reduce conflicts, then that's almost to be expected because you're probably going to need to use precedence declarations to remove them, and we'll talk about that some more in another video. But in general, if you have either one of these conflicts, it means that there's some state in which the parser doesn't know what to do, and you either need to rewrite the grammar or give it a hint as to what it should do in order to successfully parse your language.